Hello everyone, my name is Rutuja Ingre. I am from Shri Shivaji Science College, Amravati, BSc third year student from 6th semester BTZ group, and today's my seminar topic is IR spectroscopy. So let's see. Here is a content. We will see electromagnetic radiation, purpose of each electromagnetic radiation, types of vibration, introduction of IR spectroscopy means infrared spectroscopy, IR region, requirements of molecules, region of IR spectra, interpretation of IR spectra, Hooke's law, its strength and limitation. Firstly, here is the electromagnetic radiation. The source from where we get the light is sun or sunlight. Sunlight is a form of the electromagnetic radiation given off by the sun. Radiation from the sun, which is more popularly known as sunlight, is a mixture of electromagnetic waves ranging from broadcast waves, radio, microwave, infrared, RF, ultraviolet rays, visible region, gamma rays, and cosmic rays. Electromagnetic radiations, here we can read its EM radiation or EMR, is a form of radiant energy propagating through space via electromagnetic waves and particles called photons coming from the sun. Here is a diagram of EMR. Here is the source of sun. We will get ultraviolet rays, gamma rays, cosmic rays in 1 nanometer 10 degrees Celsius. And here is a broadcast band, radio, radar, microwaves, and infrared and light of colors. Now, purpose of each electromagnetic radiation is a molecular effect, ionization, electromagnetic transition, molecular vibration, rotational motion, nuclear spin transition, and here is a energy in a wavelength, high frequency, shorter wavelength, and low frequency means longer wavelength. Wavelength in we will see in centimeter. Now types of molecule vibrations. First is stretching vibrations, in which bond length changes that require more energy. This symmetrical stretching and asymmetrical stretching you can see here. Second is a bending vibration, in which bond angle changes that requires less energy, means rocking, twisting, and wagging. Now, spectroscopy. Spectroscopy is the study of the interaction between matter and radiated energy or radiation. Infrared spectroscopy, that is IR spectroscopy, is the spectroscopy that deals with the interaction of only infrared region of the electromagnetic spectrum with the matter. Here is the regions of IR radiations. Is microwave, far IR, mid IR, near IR. It's visible, and here is we see wave number, frequency, and energy. IR spectroscopy is a qualitative analytical technique that helps to indicate mainly the functional group of molecule. When the IR radiation intraradiate to the molecule, the part of molecule which is functional absorbs it. As a result of this absorption, the molecular vibration increases. After the excitation of molecular vibration, these molecules comes back to their original state by releasing that energy of certain wave number, which is recorded as transmittance of the spectrophotometer. Here is parameters. The spectrophotometer gives the spectra of certain wave by indicating the quality of wave, that is its wave number, and the quantity of wave number, how much wave is absorbed by the molecule. Transmittance. This transmittance is the fraction of incident light electromagnetic radiation at the specified wavelength that passes through a sample. That is Beat-Lambert's law. It is a ratio, so it has no unit. Here we can see infrared radiation, light or electromagnetic radiation is actually thermal radiation. It means that all of the heat which fell to us or coming into the earth from sun is nothing but IR radiation. IR is low energy, low frequency and long wavelength radiation with low wave number that can only cause an increase in molecular vibration, that is stretching and bending. So by triggering molecule vibration through irradiation with infrared light provides mostly information about the presence or absence of certain functional group. Now requirements of molecule. In order to absorb the electromagnetic radiation for a molecule, the frequency of the incident radiation matches the natural frequency of the vibration. The IF photons is absorbed and the amplitude of the vibration increases. The dipole moment of the molecule must changes as a result of a molecular vibration. The change in the dipole moment allows interaction with the alternating electrical components of the IR radiation wave. Symmetric molecules or bonds do not absorb IR radiation since there is no dipole moment. If the dipole moment of a molecule would not change, that is, as in symmetrical stretching, the absorption spectra of radiation cannot be obtained. Such spectra is called as forbidden or inactive IR spectra. If the molecule vibrates asymmetrically, the change in its dipole moment takes place so absorption spectra of this molecule can be obtained. This is called active IR spectra. Here we can see symmetrical stage, asymmetrical stage. Now the IR spectrum. There are two types of IR spectrum from which we can obtain the information about the quality of molecule. First one is functional group region. It identifies the functional group with the conscious sequence of changing stretching vibration ranges from 4000 to 1600 centimeter. And second one is fingerprint region. Identified the exact molecule with the conscious sequence of changing bonding vibrations range from 1600 to 625 centimeter. Here is a focus of your analysis of region. This is where not stretching frequencies appear, and fingerprint region is complex and difficult to internet availability. Interpretation of IR spectra. Structure information about the compound is mainly derived from the presence or absence of characteristic absorption bonds of various functional groups in the IR spectrum of the compound. A knowledge of the band of all the major functional groups will be valuable. The band position of all the major structure bonding type have been determined in a tubular form. Characteristic absorption position of the same more important common functional group are presented in given table. This table is particularly useful for correlation when the spectrum of unknown compound has been obtained. It is always more useful to make direct comparison with the spectrum of closely related compound. Here is a functional group and characteristic of absorptions. We can see S here. S means strong, M means medium, W means weak, and V used for variable. We can also calculate an appropriate value of the stretching vibrational frequency of a bond by treating the two atoms and their connecting bond to first approximation as two balls connected by a spring, acting as a simple harmonic oscillator for which the Hooke's law may be applied. According to Hooke's law, the stretching frequency is related to the masses of the atom and force constant, a measure of resistance of a bond stretching of bond by the following equation. Here is a Hooke's law. V equal to 1 pi 2 pi c in root k upon mu. V means wave number in centimeter corresponding to the vibrational frequency of the bond. C is the speed of light. K is a force constant in Dynamic centimeter, a major bond strength. The stronger than bond, the larger the K. Mu means reduced mass in atom. Here we can see atom 1, atom 2 is mass equal to m1g and atom 2 is m2g. Here mu is equals to m1 into m2 upon m1 plus m2. Now functional group and IR tables. The remainder of the presentation will be focused on the IR identification of various functional groups such as alkanes, alcohols, ketones, carboxylic acid, etc. Basic knowledge of the structure and polarities of these groups is assumed. If you need to refresh, please turn your organic chemistry textbook. The inside cover by the Wave textbook has table functional group. Here is IR spectrum of alkanes. Beside the presence of CH bonds, alkanes also show sharp medium bands corresponding to the C double bond C bond stretching vibration at about 16 to 1700 centimeter. Some alkanes might also show a bond. Here is the alkynes spectrum. Alkyne have a functional group. Their IR spectrum displays only C single bond C and CH bond vibration. Of these, the most useful are the CH bands which appear around 3000 centimeters. Since most organic molecules have such bonds, most organic molecules will display those bands in their spectrum. IR spectrum of an alcohol. The most prominent band is alcohol is due to the OH band and it appears as a strong broad band covering the range about 3000 to 3700 centimeter. The sheer size and bore shape of the band dominate the IR spectrum and make it hard to miss. IR spectrum of amines. The most characteristic band in the amines is due to the NH bond stretch and it appears as a weak to medium, somewhere broad band but not as the broad as the OH band of alcohol. This band is positioned at the left end of the spectrum in the range about 3200 to 3600 centimeter. Now is the strength and limitation. IR alone cannot determine a structure. Some signals may be ambiguous. The functional group is usually indicated. The absence of a signal is definite proof that the functional group is absent. Correspondence with the known sample is IR spectrum confine the identity of the compound. Here is reference I use BSc textbook of chemistry, 12th NCERT and some website like Wikipedia, Slideshow and Baljuice. Thank you.